what is Aldol reaction or Aldol condensation reaction? Aldehydes and are ketones. Aldehydes are ketones. Okay, containing aldehydes are ketones containing at least one alpha hydrogen. Okay, aldehydes are ketones containing at least one alpha hydrogen undergoes Aldol reaction. This is the first point you should keep in mind. Okay, aldehydes are ketones containing alpha hydrogen, at least one alpha hydrogen undergoes Aldol reaction. Okay, here what is meant by alpha hydrogen? You know very well. In the case of aldehydes, so if you have aldehyde, okay, CHO, aldehyde which is directly attached to a carbon in an organic compound, and that carbon is what we call as alpha carbon. This carbon is called alpha carbon. If this carbon contain at least one hydrogen, we call that hydrogen as alpha hydrogen. This hydrogen is called alpha hydrogen. Okay, so if aldehydes, okay, this is the meaning for alpha hydrogen. If you have aldehyde, then the aldehyde group attached to carbon. Okay, aldehyde that is directly connected to a carbon, that carbon is nothing but alpha carbon. If this carbon contain one hydrogen, at least one hydrogen, then it is called alpha hydrogen. If your aldehyde has alpha hydrogen, yes, it will undergo Aldol condensation reaction or Aldol reaction. Okay, similarly ketones. Suppose you take a ketone, right? In ketone, in both sides we have R group. Okay, suppose I have a carbon here, okay, and this carbon is called alpha carbon, and if this carbon contain hydrogen, then this hydrogen is called alpha hydrogen. So if ketone containing alpha hydrogen, that ketone also undergo Aldol reaction. Okay, now let me give few examples here. Okay, we'll see which of these following compound will undergo Aldol reaction. Okay, let me take the simplest example. Number one, this is ethanol and this is methanol, and this compound is benzaldehyde or benzene carbaldehyde. Okay, and this compound this is pyridine, and you will attach an aldehyde group here. Then we have plenty of examples. Yes, now the question is, out of these compounds, or which among these compounds undergo Aldol reaction? Okay, so we need to identify that. Okay, yeah, students, see here.
Sir,
Yes.
Sir, we have our West clusters from December 12th, sir.
Okay, okay, ma. What are the portions?
Sir, it's full portion, sir.
Full portions. Okay, right.
Sir, on 21st Wednesday, it's chemistry exam, sir.
Okay, okay, ma. Right. Yeah, we'll try to finish off. Okay. So once we finish this, I'll start coordination compounds. Okay. then we also start the full test. Okay, or what are the portions we have completed? In that we'll start the test. Okay. Now, look here. See this compound. In this compound, this is the alpha carbon. Okay, this is aldehyde group, and this is alpha carbon which contain hydrogen. Therefore, this compound undergoes Aldol reaction. See this compound, we have aldehyde group, but there is no alpha carbon. Here, no alpha carbon at all. If you have alpha carbon, then only we have to see whether alpha hydrogen is there or not. In this compound, there is no alpha carbon at all. So definitely formaldehyde does not undergo Aldol reaction. Then benzaldehyde, see this is the aldehyde group, and aldehyde attached carbon, this is the aldehyde attached carbon. Okay, you know very well in benzene, each carbon contains one hydrogen, whereas in this carbon, that hydrogen is replaced by the aldehyde group. So there is no alpha hydrogen, no alpha hydrogen. Therefore, benzaldehyde does not undergo this reaction. Similarly, here see we have pyridine 2-carbaldehyde. Okay, this is the aldehyde group, and this is the alpha carbon. And here also, each carbon contains one hydrogen, but in this carbon, that hydrogen is replaced by aldehyde group. So here also there is no alpha hydrogen. So this compound does not undergo Aldol reaction. Okay, then this one, we have aldehyde group, and this is the alpha carbon. In alpha carbon, we have only 3 methyl groups. There is no hydrogen. Okay, there is no alpha hydrogen. Therefore, this compound does not undergo Aldol. Okay, see this one. Here we have keto group. Keto group. In keto group, we usually have 2 alpha hydrogens. 2 alpha carbon, I'm sorry. So here we have 1 alpha carbon, and this side also we have alpha carbon. Okay, if any one of the alpha carbon contain 1 hydrogen, then that ketone will undergo Aldol reaction. So here this carbon has 1 hydrogen. Here we have 1 hydrogen, and this carbon has 3 hydrogens. So this compound definitely undergo Aldol reaction. See the next example. This is also a ketone. CO group is there, and this is an alpha carbon, and this is another alpha carbon. Okay, both are alpha, but this alpha carbon, in this alpha carbon there is no hydrogen, and in this carbon we have only 3 methyl group, there is no hydrogen. So in both alpha carbon, no alpha hydrogen is there, no alpha hydrogen. Therefore, this compound does not undergo Aldol reaction. Take down. You must know how to identify whether a compound undergoes Aldol reaction or not. Okay, for this is very, very important. Okay, then observe this. I'll take a simple Aldol reaction first. Simple Aldol. Simple Aldol reaction. Okay, here the word simple means in Aldol reaction 2 aldehyde molecules, okay, are 2 ketones, 1 aldehyde, 1 ketone. Okay, you require 2 molecules to undergo this Aldol reaction. You require 2 molecules. If both the molecules are same molecule, okay, and if it undergoes Aldol reaction, we call that Aldol reaction is simple. So in simple Aldol reaction, okay, 2 molecules or 2 compounds, 2 molecules or 2 compounds, okay, that undergo or that participate in the mechanism, right, that undergo Aldol reaction. That undergo Aldol reaction must be same. Must be same. If the 2 molecules are same, we call those Aldol reaction as simple Aldol reaction. For example, let me take a compound, acetaldehyde, CH3, C double bond OH. Acetaldehyde, also called ethanol. Okay, you take 2 molecules of ethanol, 2 molecules of ethanol, right? And then actually what we do, we take acetaldehyde in a container, then we'll add base. Okay, normally we use sodium hydroxide or barium hydroxide. Okay, dilute solution will add dilute sodium hydroxide. Dilute sodium hydroxide. Okay, so here see alpha carbon containing hydrogen. This compound also, both are same compound. Since both these compounds are same, this reaction is a simple Aldol reaction. And both contain alpha hydrogen, right? Both are same compound, right? Now, if we add dilute sodium hydroxide, what will happen? Okay, the reaction goes like this. Students, observe carefully. Keep this CH3 and CH group as such. Now, what happens here is, from this carbon, one alpha hydrogen is transferred to this oxygen. Okay, one alpha hydrogen of this carbon is transferred to this oxygen, and double bond becomes single bond. Then you will get a new bond between these two carbon. Okay, between the alpha carbon and the carbonyl carbon of this compound. Okay, this is what happening. So this is what going to happen. So I'll put a OH group here, because double bond becomes single bond, and transfer one H to here, so you'll get OH. And now you form a new bond between this carbon and this carbon. Now this carbon has only 2 hydrogen now. Only 2 hydrogen, and we have C double bond OH. Okay, students, observe carefully. Now we have an aldehyde group here, and this is alpha carbon and this is beta. Beta carbon has an hydroxy group. Okay, beta carbon has hydroxy group. Beta hydroxy carbonyl compounds, it may be aldehyde or ketone. Okay, if you get beta hydroxy carbonyl compound, we call those reactions as Aldol reaction. Okay, here we have aldehyde group. In beta position we have alcohol group is OL. Okay, this is the suffix we use. For aldehyde the suffix is Al. So by combining these two, we say generally that the reaction is Aldol. ALD, this is aldehyde group, and this is alcohol group, so it is Aldol. Okay, but if you take ketone, you will get beta hydroxy ketone. Okay, so in a Aldol reaction, we either get beta hydroxy aldehyde or beta hydroxy ketone. Okay, students, keep this in mind. We get beta hydroxy aldehyde, right, or we get beta hydroxy ketone. Okay, and this reaction is what we call as Aldol reaction. Okay, then if you heat this compound, what will happen? See, from this is aldehyde group, and next carbon is alpha carbon. From alpha carbon, see here we have 2 hydrogen. Let me show one hydrogen separately like this. One hydrogen. Now what will happen? This hydrogen comes out as H plus, and this bond will move over here. You'll get a double bond, and this, once this bond comes here and form a double bond, this bond breaks and comes out as OH minus. This group comes out as OH minus, and this hydrogen comes out as H plus. H plus combined with OH minus and form water. Okay, elimination of water takes place. Okay, elimination of water, then you will get this product CH3 CH double bond CH C double bond OH, and this is called Aldol condensation reaction. This entire reaction is called Aldol condensation. Aldol condensation. Okay, up to this the reaction is called Aldol reaction. Up to this the reaction is called Aldol reaction. Then if you carry out the condensation, then the complete reaction is called Aldol condensation reaction. Okay, take down. Now let me write the mechanism of this reaction, how this reaction actually taking place. What is the mechanism? Mechanism of the reaction. Okay, students, observe carefully. We have the base OH minus, sodium hydroxide. You know very well, sodium hydroxide ionizes to give Na plus and OH minus. So this OH minus comes from sodium hydroxide. Okay, OH minus, we call it as hydroxide ion, right? What it will do, it will remove H plus if it is available in the molecule. Okay, now listen, I'll take one molecule of acetaldehyde. So this is ethanol and this is your alpha carbon, right? This alpha carbon, in which this hydrogen is actually acidic. It is slightly acidic because of the carbonyl group. You have carbonyl group. Okay, because of the carbonyl group, the alpha carbon containing hydrogen will be slightly acidic. Okay, if you add a base, OH minus is a strong base. Okay, so what it will do, it will remove, right, acidic hydrogen present in a compound. So OH minus, okay, will remove this hydrogen as H plus. Will remove the hydrogen as H plus. So H plus combine with OH minus and form what is called water. You will get water. Right, and this bond, actually a bond contains 2 electrons, right? This electron is for carbon and this electron is for hydrogen. Okay, now hydrogen coming out without that electron. Okay, it comes out as H plus. Therefore, now the carbon gets more electron. Okay, the carbon gets more electron. So the carbon CH2 C double bond OH. Students, observe carefully. Now that bond has 2 electrons, so both the electron comes to carbon. Okay, actually in a covalent bond, it's a shared pair of electron, you know very well, right? One electron is for carbon, the other electron is for hydrogen. But during this removal of H plus, the hydrogen just lose the electron and comes out. Okay, hydrogen comes out as H plus. Therefore, this electron also coming to carbon. So carbon gets extra electron. That's why it become negatively charged. Okay, and this anion, carbon carrying negatively charged, is called carbanion. This carbanion is stabilized by resonance. It is stable due to resonance. Why? This lone pair comes over here, you will get double bond. You will get double bond. When this lone pair comes here, you will get double bond. And this pi bond shifts to oxygen, you will get O minus. Students, observe carefully. Listen, students, if you have carbon-carbon double bond and if you have a OH group attached to the doubly bonded carbon, we call this compound as enol. Okay, if you have carbon-carbon double bond, if you have carbon-carbon double bond and if your OH group is attached to a doubly bonded carbon, we call this type of compound as enol. Here we have enol, but the H plus is removed, so it is called enolate ion. Enolate. It is an enolate ion. Take down. So in Aldol reaction, okay, in the mechanism, if you observe, you will get an enolate ion. Okay, and listen, this carbanion that is formed, which is stabilized by resonance. Okay, then this is step 1. What happens in the next step? Students, observe carefully. Observe carefully. First step, the base removes the H plus so that you will get a carbanion. Okay, and this carbanion is stable. Why? Due to resonance. Okay, since enolate ion is formed through resonance, this mechanism is called enolate ion mechanism or enolate mechanism. Okay, you can say like that. Now in the second step, second molecule of the aldehyde, let me write like this, CH3 C double bond 2, I'll put hydrogen like this. Second molecule of aldehyde is attacked by this anion. I'll take that anion. C double bond OH. Now what will happen? This lone pair attacks this carbonyl carbon, so that one of the pi bond, double bond contain one sigma bond, one pi bond. When lone pair attacks this carbon, the pi bond shifts to oxygen, so oxygen gets negative charge. So what will happen? Let me write here, CH3CO minus H bond. Okay, you'll get a new bond between these two carbon now. Okay, and this carbon becomes CH2, C double bond OH. Since this carbon donates the lone pair and form and attacks this carbon, okay, you'll get a new bond, right? And since it is donating the electron, that carbon become neutral now. It become neutral, and this pi bond shifts to oxygen, so oxygen get minus charge. Okay, and this is the slow step in this reaction. Students, observe carefully. This is the slow step, also called rate determining step. This is the rate determining step of the reaction. Okay, there is the carbanion formed, attacks the carbonyl carbon of the next molecule. Now what will happen? Students, carbon now containing one O minus ion. Okay, whenever a carbon contain O minus ion, students, observe carefully, right? And if this is a saturated carbon, okay, observe carefully, this ion is called alkoxide ion. Alkoxide ion. Alkoxide ion. Alkoxide ions are also basic in nature. They are also basic. So here, see, we have carbon. This carbon contains 4 sigma bond. Okay, it's a saturated carbon, and that carbon has a O minus. So it is an alkoxide ion. Alkoxide ion is basic. What it will do? It will remove one hydrogen from water. Let me show the water molecule like this. Now what it will do? It will remove one hydrogen from water molecule. Okay, one H plus comes out, and that H plus get attached with this, and again this H2 now comes out as OH minus. Okay, a OH minus coming out, right? And what we get? We get this product CH3, CH, and now this O minus become OH bond, CH2, C double bond OH. You'll get this product. You'll get this product, and this is called beta hydroxyaldehyde, also called Aldol. Okay, take down. This is the mechanism of the reaction. And remember the rate determining step. Okay, this step is the rate determining step here. Up to this reaction is called Aldol reaction. Then this undergo, suppose if you heat this compound, what will happen? Students, see carefully. Here I have aldehyde group, carbonyl group. The next carbon is called alpha carbon. If alpha carbon contain hydrogen, those hydrogen will be acidic. Remember this, whether it is aldehyde or ketone, if adjacent carbon called alpha carbon, if alpha carbon contain at least one hydrogen, or alpha carbon contain hydrogen, those hydrogens are acidic in nature. So now you have 2 hydrogen. Out of 2 hydrogen, let me take 1 hydrogen like this. On heating, what will happen? This hydrogen comes out as H plus, because in the medium we have water molecule, we have base. Okay, so one hydrogen comes out as H plus, and this bond will go here. When this bond goes here, OH comes out as OH minus. On heating, this reaction will occur. Okay, listen, we are removing water without adding any catalyst. Why this reaction happening? It is because of this carbonyl group. Okay, this carbonyl group is helping this dehydrogenation process. Dehydration process, I'm sorry. So H plus is removed here, and this bond will go here, and this OH minus will come out. So what we get? We get CH3, CH double bond, CH, C double bond OH. Okay, right? We get this product, and this is called the Aldol condensation reaction. Once you remove water, the reaction is called condensation reaction. Okay, take down. Normally, if you have hydrogen attached to one carbon and OH attached in the next carbon, if you want to remove water, you should add some dehydrating agent. Okay, you should add some dehydrating agent. Now, without adding dehydrating agent, I am removing water. This is possible because of this carbonyl group. Okay, remember that. Okay, so this is the mechanism of Aldol reaction. So here I have given a simple Aldol reaction. Okay, then there are plenty of examples actually. Now I'll take a second reaction. I'll take acetone, also called propanone. Okay, take 2 molecules of propanone. First add dilute base sodium hydroxide. You'll get some product. Then heat the compound. You'll get the final product. Up to this, the reaction is called Aldol reaction. Then up to this, okay, after heating, that reaction is called Aldol condensation reaction. Now I'm not going to write the mechanism. I'm going to give you the product. How to identify this Aldol product and Aldol condensation product? How to identify that? Very simple. In this case, the two compounds are same, right? The two compounds are same. Therefore, and we have alpha hydrogen. Alpha hydrogen is there. Therefore, definitely this compound undergoes Aldol reaction. And since the two compounds are same, it is an simple Aldol condensation. Okay. How to identify the product? Very simple. I have told you, from one molecule, okay, from the alpha carbon, you transfer one hydrogen to this oxygen. You transfer one hydrogen to this oxygen so that this double bond becomes single bond and connect this carbon to the alpha carbon of this. Okay, that's all. That's the step you have to do. You will get this product. Okay, so let me write the first product here. What is the first product? See here, CH3, C. Now double bond becomes single bond. I'll attach one OH here. I'll put this methyl group down. Okay, then you connect this carbon and this carbon. See, from this carbon we have transferred one hydrogen. Therefore, we have only two hydrogen here, CH2, CO, CH3. Okay, you'll get beta hydroxy. This is alpha, this is beta. You'll get beta hydroxy ketone, and beta hydroxy ketone is the aldol product. Aldol product. Now, what happens on heating? On heating, see this, we have a carbonyl group here. Carbonyl group here, and adjacent carbon contain hydrogen. That hydrogen is acidic. So out of two hydrogen, I'll take one hydrogen and I'll remove that. Hydrogen is H plus, and this bond will move over here, and you'll get OH comes out. Okay, and you'll get this product, that is CH3, C, CH3, double bond, CH, CO, CH3. This is the product. Second, final product, aldol condensation product. Take down. Okay, now let me take another example. Now I'll take this compound. Students, observe carefully. Whatever may be the compound, okay, I have taken cyclopentanone now. Cyclopentanone. See, in the examination, sometimes they'll give like this. Cyclopentanone, they'll put dilute sodium hydroxide. Okay, and followed by heating. What will be the product? They won't give, usually they won't give two molecules. Okay, so if it is given like this, be careful. This is the alpha carbon. Alpha carbon contain hydrogen. So this reaction, and we have dilute sodium hydroxide, is an aldol reaction, very clear. Okay, and how to identify the product? See this? I'll take two molecules. Two molecule, and this is an alpha carbon, right? Which this carbon contain actually two hydrogen. Observe carefully, it contain two hydrogen. Now, how will you get the aldol product? From one molecule transfer, and see here, if they give only one compound, for the reaction you take two molecules of the same compound. So it is a simple Aldol reaction. Okay, transfer one hydrogen to the oxygen atom of the next compound so that this bond becomes single bond, and you connect this carbon with this carbon. Okay, so that is the Aldol product. So let me write the Aldol product first. Cyclopentanone. Here this carbon become, that group become OH, and you'll get a new bond between this carbon and the alpha carbon of this compound. Let me draw the alpha carbon like this. Okay, you will get a product like this. This is the Aldol product. Okay, then on heating, if you heat this, this carbon has one more hydrogen, correct? We have two hydrogen here. One hydrogen is transferred, remaining one hydrogen is there. So on heating, this hydrogen comes out, this bond will go here, and this OH minus will come out. So you will get a compound with a double bond like this. Let me show like this. You have a double bond connected to this compound. Same reaction. The reactant is different, that's all. The reaction is same. So up to this, the reaction is called Aldol reaction. Then after heating, you'll get this product, and this reaction, the complete reaction is called Aldol condensation reaction. Take down. Okay, now here I have given simple Aldol reaction. Now let me take one example for crossed Aldol condensation. Crossed or cross Aldol condensation. Aldol reaction or Aldol condensation reaction. Cross Aldol means you should take two different compounds. Okay, now when you take two different compounds, okay, there is a problem. All right, what are the problems? Listen, suppose I'll take acetaldehyde and I'll mix it with the propanone. I have acetaldehyde, I'll mix it with the propanone. Then I'll put dilute sodium hydroxide. So what are the products we get? I'm not heating. So if you don't heat, you will get only Aldol product. What are the possible products? Students, observe carefully. I'll take this molecule as A and this molecule as B because they are different. If you have two different compounds which undergo Aldol reaction, you'll get cross Aldol. And here, note this carefully. This compound contain alpha hydrogen. This compound also contain alpha hydrogen. Both compound contain alpha hydrogen. So individually they are capable to undergo Aldol. Okay, ethanol can undergo Aldol individually. Propanone can also undergo Aldol reaction individually. But now it is given mixed. Okay, the two compounds are mixed, and then dilute sodium hydroxide is added. So here there are different possibilities. What are the possibilities? Since A is capable to undergo Aldol individually, A may react with A, will give one product. B may react with B, you'll get one product, and A reacts with B, you'll get another product, and B reacts with A, you'll get different product. See, students, observe carefully. A plus B, B plus A, what is the meaning? Listen, from which compound OH minus remove H plus? Okay, if H plus is removed from A, you will get enolate ion of A. If H plus is removed from B, you will get enolate ion of B. So you will get four different products. Okay, let me write this. These two are simple. They are a simple Aldol product. Okay, so suppose I'll take this molecule. See, students, CH3, C double bond O, H. I'll take molecule A and another molecule of A. I'll give all the possible product, and I'm just giving you how to identify the possible products. Okay, so what happens here? First transfer one H2 from one molecule, you transfer H2 oxygen, you'll get OH group, and then connect the two carbon. So you'll get this product. This is the first product, CH3. Let me write this product first. OH, connect this carbon with the CH2, C double bond OH. This is one possible product. This is obtained by the reaction of A with A. Okay, then second possible product, okay, B, we are with B, because B can individually undergo aldol. So let me write one B molecule like this and another B molecule like this. Okay, what will happen? From this alpha carbon, you transfer one hydrogen to the oxygen and then connect carbonyl carbon with the alpha carbon. Okay, so what we get is CH3, C, make this double bond single bond, put OH group, CH3, CH2, CO, CH3. You'll get this product. This is another possible product. Okay, this is also aldol product. Okay, now A with B. Students observe carefully. A with B. I'll keep A as such. What is A? A is acetaldehyde. I'll keep A as such. Then I'll take B. B is acetone, propanone. Okay, I'm going to transfer one H plus from B to A. Okay, so that means I'm creating enolate ion of B. I'm creating enolate OH. First step, see the mechanism. OH minus will remove H plus here, and so that you will get a carbon ion. You will get an enolate ion, right? So we are creating enolate ion of B that is reacting, that is attacking with this compound A. So now what will happen? One hydrogen is transferred here and connect this to carbon. Okay, so what we get is CH3, C, OH, H, CH2, CO, CH3. This is one possible product. Okay, and this is A with B. Okay, B is forming enolate ion, B becoming the nucleophile, and that is attacking here. Next, B with A. I'll keep B as such. B, I'll keep B as such. Now with A, what is A? CH3, C double bond OH, acetaldehyde. Transfer one hydrogen. Students, this arrow mark I am just showing you for understanding or to identifying the product. Mechanism is different. Okay, just to identify product easily, I am just writing like this. So transfer one hydrogen to oxygen, so that this double bond becomes single bond, and connect this carbon with this carbon. Okay, just for identifying the product I am writing this. CH2, C double bond OH. Observe this, student. All the four products are different. This is AA product. This is BB product. This is A with the B enolate ion. This is B with A enolate ion. Okay, take note. So we get the mixture of these four products. We get the mixture of these four products. Okay, take note. So in this reaction, you'll get four products, not a single product. You'll get four products, four different products. Right? Take note. Now, students observe carefully. Suppose sometimes they'll give compound like this. See, I'll give a reaction of this type, crossed aldol reaction. Students observe carefully. I'll take benzaldehyde. Observe carefully. I'll take benzaldehyde. Then I'll take acetaldehyde. I'll take the mixture of these two. I'm mixing benzaldehyde and acetaldehyde, and I'm adding dilute sodium hydroxide. What is the product? Will this undergo aldol reaction or not? The first question is this. Will this is this reaction undergo aldol reaction? Is aldol reaction possible here? The answer is this. Listen, student. Here we have aldehyde group, and this is the alpha hydrogen, but there is no alpha hydrogen here. That means this compound does not undergo aldol individually. Whereas the second compound, yes, here we have alpha hydrogen. Alpha hydrogen is there. So this compound can undergo aldol. But since we are having mixture, okay, this is the only molecule can form enolate. This can form enolate. So I'll take this molecule as A and this molecule as B. Students observe carefully. B can undergo aldol reaction individually. That means B will react with B. This is one possibility. If B reacts with B, what we get? CH3, C double bond O, I'll put H here. Then another molecule, I'll write CH3, C double bond OH, second molecule. Okay, transfer one hydrogen to here, double bond becomes single bond and connect these two carbon. So what product we get is that CH3, C single bond OH, H, CH2, C double bond OH. This is the product we get. Okay, B with B, because B can undergo Aldol reaction individually. Can A undergo this Aldol reaction, student? Can A undergo Aldol reaction individually? Students, try to answer this. Can A undergo Aldol reaction individually? Hello?
Sir, yes, sir.
Students, are you listening or not?
Sir, are you able to hear me, sir?
Yeah, yes, Tejasvi.
Yes, sir.
Will A undergo Aldol reaction individually?
Yes, sir.
Yeah, how no alpha
No,
hydrogen?
sir.
Right?
No, sir. Benzaldehyde.
See, students, you are not listening, I think so. You are doing something else.
No, sir.
Please focus here, okay? Try to focus here. Try to focus here. See, in A, compound A, there is no alpha hydrogen. Then how can this molecule undergo aldol individually? So this is not possible. This A and A never form enolate ion. There is no alpha hydrogen. Whereas A with B will undergo this reaction. Why? Because B can form enolate and that can attack the nucleophile, the molecule of this, carbonyl group of this. So this is possible. This is possible. How? So let me take the A molecule. Let me take the A molecule. This is the A molecule, benzaldehyde. Plus B has alpha hydrogen, so it can form enolate ion. B has alpha hydrogen. So transfer one hydrogen to this oxygen and connect the two carbon. Okay. So you will get this product. Students, observe carefully. This is very, very important. Even if there is no alpha hydrogen in a compound, in aldehyde or ketone, if the other compound has alpha hydrogen, aldol reaction, cross aldol reaction will take place. Cross aldol, this is cross aldol. Okay, and what we get is this product. We get this product. This reaction will happen. Okay, what about B with A? Can A form enolate ion, students? Can A form enolate? A has no alpha hydrogen here. There is no alpha hydrogen. So A cannot form enolate. Therefore, this product never form. Only compound containing alpha hydrogen form enolate ion and undergo nucleophilic reaction. Okay, take 2. So in this reaction, we get only two different products. Only two products. See the previous example and this example, there is a difference. In the last case, in the last example, both A and B can undergo aldol individually, whereas here A cannot undergo individually, aldol reaction individually, only B can undergo. Right? In this situation, you'll get two different products. These are the two different products. One is BB product, the other one is A with the B product. Okay, note down. Okay, this is all about cross aldol condensation. Keep this in mind. Now let me go to the next one. Is this clear, student? Any doubt?
Yes, sir. No doubt, sir.
Yeah, right. Try to focus here, student. Try to focus here. Okay, you are simply switching, watching the video, and you are doing something else, I think so. Try to focus here. Yeah, now. So with this we have completed aldol. Now let me take another reaction called Cannizaro reaction. Cannizaro reaction. Both these reactions are very important, especially for competitive examinations. Cannizaro reaction. Okay. In Cannizaro reaction, students observe carefully. In Cannizaro reactions, only aldehydes. Okay, aldehydes, only aldehydes. Aldehydes containing no alpha hydrogen. Observe carefully. I am using the word containing. Containing no alpha hydrogen. There should not be any alpha hydrogen. Okay, aldehydes with no alpha hydrogen undergoes Cannizaro reaction. That's the point. Undergoes Cannizaro reaction. Note down. Undergoes Cannizaro reaction. Aldehydes with no alpha hydrogen undergoes Cannizaro reaction. Okay, take down. Now, students, this is very important point. Before going to see Cannizaro reaction, among aldehydes and ketones, okay, which one undergo nucleophilic reaction or nucleophilic addition reaction faster? Okay, so this is very important. Just for your understanding, I am giving this note. Okay, rate of nucleophilic addition. Okay, rate of nucleophilic addition. I am going to give this order first. I am going to give two orders, actually two important orders of reaction. First one is this. Students, observe carefully. Very important. Acid chlorides usually undergo nucleophilic reaction faster. Okay, if you put any nucleophile, even weak nucleophile can make nucleophilic addition with the acid chloride. Then next one is acid anhydrides. Remember this list, very important. Right? Second one, after acid chloride, the next one is acid anhydride. Will undergo nucleophilic addition reaction faster. After this we have aldehyde. After aldehyde, I'll write here. We don't have space there. After aldehyde, we have ketones. Let me put this as R1, this as R2, two different group like that. Okay. Next one is ketone. So aldehydes are more reactive in nucleophilic addition. Students, observe carefully. Aldehydes undergo nucleophilic addition faster because you have hydrogen here, so steric crowding is less. So nucleophile can easily attack this carbon. That's the point. Okay. Then after ketone, we have ester group. After ester group, we have carboxylic acids. After carboxylic acid, we have amide, CONH2 amide. Amides. Remember this list, very important. Now, among aldehydes and ketones, I am going to focus on these two. Among aldehydes and ketones, how the rate of addition will vary. Okay, and this is very important. Among aldehydes and ketones, formaldehyde is most reactive. Students, observe carefully. Among aldehydes and ketones, formaldehyde is most reactive, highly reactive. It will undergo nucleophilic reaction, okay, very fast, right, compared to other aldehydes and ketones. So formaldehyde, then other aliphatic aldehydes. After this, we have benzaldehyde. Compared to aliphatic aldehyde, benzaldehyde is less reactive under nucleophilic addition reaction. After aldehyde, we have ketone, right? After this, we have aliphatic ketone. Then we have aromatic ketone, where one side we have aromatic group, the other side we have aliphatic group. Then we have both side aromatic, which is least reactive among the ketones. So remember this is very important, student. Okay, Cannizaro reaction Cannizaro reaction involves nucleophilic addition. Okay, so whenever Cannizaro reaction is given, immediately you should remember this. You should say this order. Okay, which is most reactive? Formaldehyde is most reactive. Right, then other aliphatic aldehyde. Benzaldehyde is less reactive compared to formaldehyde. Remember this order, okay? Yeah. Is this clear, student? Any doubt here?
No doubt, sir.
Note down, note down. Very, very important. This is very useful for the competitive examinations. Okay, now I'll go back to Cannizaro reaction. So remember, for Cannizaro reaction, okay, aldehyde, yeah, for Cannizaro reaction, aldehydes with no alpha hydrogen, there should not be any alpha hydrogen. Only those aldehydes undergo Cannizaro reaction. Ketones, students, I am giving only, okay, only aldehydes. Only aldehydes, not ketones. Only aldehydes undergo Cannizaro reaction, that's the point. Okay, now listen. Students, let me take one example. First, I'll take simple Cannizaro. Simple Cannizaro. Simple Cannizaro means both compounds are same. That's the meaning, right? Both the compounds are same. You should take two compounds. Okay. Here, see, take two compounds. We should take two compounds. Two compounds. The two compounds are same. The two compounds are same. That's why it is called simple Cannizaro. In Cannizaro, students observe carefully, one compound will undergo oxidation, okay, and the other compound undergo reduction, right? So here one compound undergo oxidation, self oxidation will occur, and self reduction also occur, self reduction. Okay, self oxidation and self reduction occurs, right? One compound will form aldehyde. No, we are taking aldehyde. So because of self oxidation, you will get the acid. Because of self reduction, the other aldehyde will form alcohol. So remember, in Cannizaro reaction, one product should be acid, the other product should be alcohol. Okay, remember this point. Now let me take one example. Okay, before that, let me ask one question. I'll give few compounds. You try to tell me which among these compounds undergo Cannizaro. Okay, make it fast. Number 1, 2, 3, 4, 5, 6. Yes, student. See the first one. Here we have aldehyde group, but there is no alpha hydrogen, right? Here no alpha hydrogen.
Yes, sir.
So first one will undergo Cannizaro, am I right?
Yes, sir.
What about the second one?
Yes, sir.
Second one, we have aldehyde group, no alpha carbon at all. Therefore, definitely this will undergo Cannizaro reaction. What about the third one?
No, sir.
No,
No,
sir.
because this is alpha hydrogen. This is alpha carbon which contain alpha hydrogen. So this compound does not undergo Cannizaro. What about the fourth one?
Yes, sir.
We have aldehyde group and this is the alpha carbon. In alpha carbon we have only 3 methyl group. There is no hydrogen. So definitely it will undergo Cannizaro. What about the fifth one? We have aldehyde group and this carbon is the alpha carbon, am I right?
Yes, sir.
In alpha carbon, see, we have a CH3 group, and this side we have CH2, CH2. This side also we have CH2, CH. There is no hydrogen, so no alpha hydrogen, no alpha hydrogen. So definitely this will undergo Aldol. I'm sorry, Cannizaro. Similarly this, okay, this is also an under Cannizaro because in this carbon there is no hydrogen. Okay, so you must know how to identify the products or the compounds which undergo Cannizaro reaction, right? Now let me give an example for simple aldol, simple Cannizaro, I'm sorry. I'll take one example, simple Cannizaro. Students observe carefully. If I give sometimes they'll give in the examination, they'll give like this, they'll give benzaldehyde and they'll put strong sodium hydroxide, that is a concentrated sodium hydroxide. Usually we'll add 50% sodium hydroxide solution, 50%, very strong, very concentrated, highly concentrated sodium hydroxide is added here. So if you have, see this compound and there is no alpha hydrogen, correct? There is no alpha hydrogen and we are adding concentrated strong base. So this reaction is a Cannizaro reaction. You must know, you must identify that first. In the examination they'll give simply like this, they won't give two molecules and all. Okay, sometimes they'll give one molecule and they'll put 50% sodium hydroxide. Okay, see this molecule, first identify this, identify whether the aldehyde contain alpha hydrogen or not. There is no alpha hydrogen, first point, and in the arrow mark it is given 50% sodium hydroxide, concentrated sodium hydroxide. Yes, it is an example for Cannizaro reaction. Once you identify that, what you have to do, you should write the product. You should take two molecule actually. So let me take two molecule, one and the second one. And this is an example for self-oxidation, self-reduction reaction. So what happens here? What happens? One molecule undergo oxidation. When aldehyde undergo oxidation, you'll get acid. You'll get COOH, but the medium has base. Therefore, you will never get acid. You will get the corresponding salt. You will get the corresponding salt. And what happened to the second molecule? Second molecule undergo reduction, and you'll get the reduction product CH2OH, alcohol. Okay. When aldehyde undergo oxidation, you'll get acid. When aldehyde undergo reduction, you'll get the corresponding primary alcohol. Take note. You'll get primary alcohol. And what is the mechanism? How this reaction taking place? Mechanism. Mechanism is very simple. See, student, I'll take first one molecule, and we are adding base, which produce OH minus ion. Now, what will happen? The base will attack this carbonyl carbon, so that one pi bond shifts to oxygen. When pi bond moves over to oxygen, oxygen becomes negative charge. So what will happen here? See, oxygen get negative charge, and now you will get a new bond between this carbon and this OH. Since this oxygen donate the lone pair and form a bond, okay, the negative charge will disappear. It become neutral because it has donated. Okay, this is the first step, students, and second step is very, very important. What will happen? This ion, okay, it will react with the second molecule. Let me write the second molecule here. Students, observe carefully. I'll take I'll take the second molecule here. Second molecule. What will happen? This minus charge will come over here. You will get again C double bond O. When this minus comes here, this hydrogen comes with the bond pair. Students, observe carefully. When hydrogen comes without bond pair, you will get H plus. If hydrogen comes with the bond pair, you will get H minus. H minus is called hydride ion. Hydride ion. So hydride ion is transferred from one molecule to the other molecule. This hydride ion will attack here. Okay, students, observe carefully. This hydride here, hydride transfer takes place. Hydride transfer takes place from one molecule to other molecule, and this is the slow step or the rate determining step of the reaction. Okay, for this hydride transfer to takes place, students, this aldehyde should be highly reactive. Okay, but in this case it is a simple Cannizaro reaction, so both aldehydes are same. But if two different aldehydes are given, students, you should choose this aldehyde should be highly reactive. Okay, so so what will happen? Okay, we'll discuss that as we go along. Okay, so here hydrate transfer takes place. You'll get this product. Okay, so when hydride ion attacks this carbon, this pi bond will shift to oxygen, so you'll get CO minus H. Okay, I have told you already. See, this carbon is a saturated carbon, correct? All the 4 bonds are single bond and it has one O minus. If you have CO minus in which the carbon has 3 single bonds or all the 4 single bonds, it is called saturated carbon, and this is called alkoxide ion, which is highly basic. You will get an alkoxide ion. It's a basic ion. What it will do? It will remove one H plus. Okay. Okay. One more information. See here, hydride is transferred from this molecule to this molecule. You will get this ion. And what happened to that? What happened to that? Here, this minus comes back. You will get C double bond O and OH. You will get an acid. But this is a base. Alkoxide ion is a base. So what it will do? It will remove one H plus from this acid. So H plus is removed here and H plus goes to this oxygen, because alkoxide ion is more basic. And what we get, let me write in the next page. What we get is this. Students, what we get here is this H plus is transferred here, so we get this compound. See, OH, and this I can write as simply CH2 plus, and this become C double bond O minus. See, here also we have CO minus, but this is not alkoxide because this carbon has double bond O. It is carboxylate ion. Carboxylate ion is stable. Students, carboxylate ion is stable. Remember that. Okay, and this is the product we get. Okay, one form benzyl. This compound is called benzyl alcohol. Common name. Benzyl alcohol is one product. The other product is sodium benzoate. Sodium ion get attached with this. Take down. You'll get sodium benzoate. Right, students, observe carefully. This is very important, student. This is very important. This first step, see here. OH minus should attack the carbonyl carbon of some aldehyde, and this aldehyde should be more reactive towards nucleophilic addition. This is the rate determining step, no doubt in that. This is not rate determining step, but the first step decides which aldehyde will undergo this reaction. Will undergo a nucleophilic attack with OH minus. Right? Why I'm saying this? Listen, we'll discuss that. Before that, I'll complete this one, second reaction. Suppose I'll take 2 molecules of formaldehyde. There is no alpha carbon, so definitely there is no alpha hydrogen. Now I'll put strong concentrated base. Okay, 50% sodium hydroxide solution. Sodium hydroxide, or you can put potassium hydroxide. Okay, what is required is concentrated strong base. Okay, now what will be the product? One will undergo oxidation and become acid, but I have told you, since the medium is basic, you will never get acid, you will get the corresponding salt. Plus the other compound will undergo reduction. Okay, when CH2 undergo reduction, you will get CH2OH. So this is nothing but CH3OH. You will get methanol. So one product is methanol, the other product is sodium formate or sodium methanoate. Take down. These two are examples I have given for simple Cannizaro. simple Cannizaro. Now let me give an example for cross Cannizaro reaction. Crossed Cannizaro reaction. What is cross Cannizaro? You should take two different molecules. Students, observe carefully. Now let me take benzaldehyde and another molecule formaldehyde. Now I'll put 50% sodium hydroxide, concentrated base. Students, out of this molecule, which one is attacked by OH minus? See, let me show the first that page again. Which molecule is attacked by OH minus? That will form the acid. Students, I repeat. Listen, the aldehyde which is attacked by OH minus. I repeat, students, observe carefully. The aldehyde which is attacked by OH minus will actually form the acid. Okay. So now we have two aldehydes here. Which one can undergo nucleophilic addition faster? Out of these two, students.
Second one, sir.
Which one can undergo nucleophilic addition faster? I have given the list already. Formaldehyde, right? Okay.
Yes, sir.
Formaldehyde undergo nucleophilic addition reaction faster. So formaldehyde, right, it is attacked by OH minus faster. Therefore this will undergo oxidation and become acid. So formaldehyde will form the corresponding acid HCOOH, but since the medium is basic, you will get O minus Na plus. You will get a salt. And the benzaldehyde undergoes reduction, you will get benzyl alcohol. Very simple, student. Very simple. Take down. Now I will ask another question. Try to answer this. I'll take this aldehyde. You know very well, this aldehyde undergo Cannizaro reaction because there is no alpha hydrogen. And I'll take formaldehyde. I'll put 50% sodium hydroxide. Can anyone tell me which one undergo oxidation and which one undergo reduction? Which one is attacked by nucleophile faster? Which one undergo nucleophilic addition faster?
Second one, sir.
Again formaldehyde, correct? Formaldehyde I have given already. Formaldehyde is most reactive. See here, I have given this point already. Anyway, let me one second. Yeah, see this. This is the nucleophilic. This is a rate in which nucleophilic addition occurs on the aldehydes and ketones, right? Formaldehyde is most reactive out of all other aldehydes and ketones. Formaldehyde is most reactive. Therefore, if Cannizaro reaction is given, see the given compound and in which one nucleophilic attack, that is OH minus attack, occurs faster. You see that? Yes, no doubt. Formaldehyde undergoes nucleophilic addition faster, right? Listen, the one which is attacked by OH minus faster will undergo oxidation. So you will get HCOOH, but since the medium is basic, you will get the corresponding salt. And the other one undergo reduction. So you will get CH3, 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 okay, and this aldehyde group becomes CH2OH. Is this clear, student? Whatever may be the compound, you can easily identify it. Right? Take down. This is what we call as cross Cannizaro reaction. Aldol and cross Cannizaro reactions are very important for competitive examinations.